I should have loosened that first. Be sure you pick up one of the handouts that I have set out for you. Thought you might appreciate it. Deep red sunset. Also, they light it up with various colored lights from time to time. Yeah. Welcome back from your holiday. I see that most of you survived. No one looks really bad. I had a good weekend. For 4th of July, my wife surprised me giving me a big smoker. And so Saturday, I made a meatloaf, smoked with bacon on it. And it was very good. And then yesterday, I made ribs, St. Louis style, and brisket, both chopped and sliced. And it came out wonderful as well. And spent a lot of times walking my dogs through the woods. And so that's very relaxing. Well, that said, let's talk about the test just for a moment. Now, you have your first exam on Thursday. I will allow you to come in as early as 6:30 if you want to get an early start. Okay? Do you have to? No. May you? Yes. Okay? It's also a sneaky way for you to get extra time if you think you will. Or not so sneaky way. At any rate, you may do that if you wish, and maybe get out of here a little sooner Thursday night. The handout that I have for you today, I call the list of citations. Now, what those citations are, is they are look-alike problems to the ones in the test. If you notice on each one of these, it first gives you a page number or a section number. Happens to be from your e-text, but it would be from a hard copy text as well. So you have a page number and you have various problem numbers that are somewhat similar to that particular problem number. That 1, 2, 3, 4 up through 29 actually corresponds to problems 1 through 29 in order on the test. Now, also, if you look out behind the citation, meaning the page and problem numbers, you'll see that I put a little comment as to the type or style of problem that it is, to give you a little further hint in terms of the study. Now, Alex, it's due Sunday night. The test is Thursday. There's stuff on the test we're covering tonight. Okay. My recommendation is that you finish your Alex before the test. Yes. Okay, and that's my recommendation to you. I mean, no one's going to make you do it. No one's going to check and see if you did. I mean, I'll check Monday to see if everybody got their assignment in, but that's not the same thing. But I do recommend that you do the Alex prior to the test. I would say that it would greatly increase your prospects for a good grade, okay, or a better grade. Well, any questions about the test before I actually get started on the material for tonight? Yes.
So for number 4, there's nothing after the number set. There's a comma and a blank space.
Yeah, I didn't put a comment.
So are those just
Look at the pages and see what it is.
okay? Just
I mean, these come out of problem sets. They're in the e-text. There's a whole 7 or 8 or 9 pages of explanation prior to that you can go back and look at.
I've also been having a hard time finding the textbook.
It's an e-text that's when you sign into Alex.
Okay.
When you sign into Alex, let's see. No, I'm not signed into Blackboard right now, so I can't show you these. If I were signed into Blackboard, I could show you real easy, but there's a link down there in either information or course materials that you sign into Alex. And then on the home page of Alex, over to the left top is your e-text, and you click on it.
Okay.
Okay. Any other questions? All right. Well, let's go ahead and get started then. Okay, where we left off last week, we were talking about different kinds of lines and how you identify them. Well, tonight we're going to start with vertical lines and horizontal lines. They have special characteristics that are different from all other lines. Okay. Okay. Here are the rules for vertical and horizontal lines. This might be worth writing down, contrary to some things I've done. This business right here, x equals k, where k is a constant, might be x equals 5 or -3 or some number is what that means. Same down here. Notice the difference on these vertical and horizontal lines. In a vertical line, you only have different x values. In a horizontal line, you only have different y values. Now, that seems the opposite of what it ought to be, doesn't it? Let's think about that. a vertical line. Okay, here's the axis. If I pick a point out here, x equals 3, then I'm going to have a vertical line right there through x equals 3. What that's saying is that no matter what y is, x is always 3. And by the way, it'll always be parallel to the y-axis. Of a similar nature, on the horizontal line rule, let's pick this point right here, y equals -4. Okay? The equation y equals -4 would give me this horizontal line that is always 4 down. Okay? Because horizontal is horizontal, no matter what. All this equation does is tell you how far up or down that horizontal line is. Just as well as this one just tells you how far left or right it is. And that's why the difference in those two equations and all others. All the others will have both an x and a y. But if you see just x equals or y equals, you know that's horizontal or vertical. Okay, also by definition, any horizontal line is perpendicular to any vertical line. That just kind of makes sense, doesn't it? Now, here's something else that I want you to add to these. For a vertical line, the slope is undefined. For a horizontal line, the slope is 0. Now, if I ever see an answer that says no slope on either one of those, I'm going to count it totally wrong. They have a slope. It is either 0 or it is undefined. Now, how did they get that undefined distance? Hopefully you remember from last week, we dealt with some questions that looked like this, where this was the angle of the slope, right? And from some base point, we would go up and over, rise over, run kind of a thing, right? Okay. Well, let's call this some value A over B. Just, so much up, so much over. Okay. Now then, if we looked at a piece of graph paper and we went up 1 and over 1, up 1 over 1, up 1 over 1, this thing would be at a 45-degree angle. By the way, the equation in that one would be x equals y, because the slope is 1 or y equals x. Because the slope is 1, it's up 1 over 1, up 1 over 1. Okay? Now then, what if we change this slope? Okay, what is the slope? M equals 1 over 1. What if we change this slope to 2 over 1? Okay, that value right there. Well, then we're going to go up 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. And we're going to get, oops, that should be going, if I draw this correctly, it should go through that center. Okay, we're going to get a line that's at a steeper angle, right? Well, let's play the what if game again. What if M is 5 over 1? Well, then we're gonna go up 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And we're gonna still yet get a much steeper angle or slope. What's happening as this increases? The line is getting steeper, isn't it? Well, what if I had m equals 100 over 1? We're just barely going to be able to tell that it's not on the y-axis. Okay, you see that? But what if we had 1,000 over 1? It's still going to get closer to the y-axis, but not quite touching it yet. Or 10,000 to 1, even closer, but not yet touching. Okay, and 1,000,000 to 1 slope. Very close, but not touching. Now, why do we call vertical lines undefined slope? Because they are infinitely steep. You're not going to find it written that way in any math book, but in reality, that's what it is. And why do we call it undefined, which is the answer I want you to put, is because we can never quite measure how steep it is. Okay? And that's why a vertical line has undefined slope. Kind of a long story or a short payoff, but you need to understand that. Okay? As it gets steeper, it's approaching infinity, but we never can quite measure where is infinity. Okay? So, enough of that. Now let's go
Would
on.
we be fine on the test if we just write slope is undefined? Or would we find if that's?
If that's the answer, I mean, yeah.
Yeah, okay, gotcha, just making sure that.
Yes, that would be fine. Okay, now, problem. 5x equals -10. What kind of a line is this? That is a vertical line because it tells you the spacing on x from the origin. Okay, well, -10 divided by 5 happens to be -2. Okay, so this equation simplifies to that. So that's our actual equation. Now we're going to graph that. Where is -2 for the x value? 1, -2. That's going to be a vertical line right here at -2. Now, is there a y-intercept on this? No, because it never crosses the y-axis. Okay? There's the line. Okay, what about this one? Again, it's a vertical line. Here's an XY table. We pick 6 for X, and if we can pick any value for Y, it'll go with that 6, and you graph it, and you get something like that. So why bother? Work smarter, not hard. Okay, X equals -4. Gonna be another vertical line. Okay, and I think this is a totally different problem.
Yeah. That'll be a.
Okay, we got y equals 2. Now we have a horizontal line up here at 2. Now, there it is. This time it's saying it never crosses the x-axis. So there is no x-intercept, but there certainly is a y-intercept this time. It's 2. Look at the shape of what the point looks like on that. Well, that's the y-intercept. Okay, what about this one? Well, we got to do a little bit of simplifying, but ultimately it's going to be a horizontal line. So we divide both sides by 4, and we get y equal -7/4. Well, 7/4 is the same thing as 1 3/4 negative. Okay. Well, here's an XY table. I mean, you can do that. No matter what x is, y is always going to be 7/4. There it is. Okay. I've actually already taught you this. What are the x and y intercepts? The y-intercept is where it crosses the y-axis. The x-intercept is where a line crosses the x-axis. What are the characteristic point values? For the y-intercept, x will always be 0 because it's on the y-axis. For the x-intercept, whether it's over here or over here, y will always be 0 because it's neither up nor down. Okay, we actually have done this already. Don't write this down. Okay, we got this thing. Okay. How do we find the intercepts? Well, you want the x or y intercept first. Doesn't matter. Well, let's do this. Let's choose the value where x is 0. Okay? So if we let x be 0, 3 times 0 minus 2y equals 6. Okay, that wipes out. -2y equals 6. Y equals -3. Okay, what does that do? That gives us the point 0, -3. Okay. Where is that? 0 and -3. That is our what kind of intercept? Y-intercept. Okay. For the x-intercept, say we took 3x minus 2 times 0 equals 6. I should probably put those in parentheses. Okay. This wipes out. 3x equals 6, x equals 2, gives us the point 2, 0. Okay, so we graph that. 1, 2, 0, and we graph the equation. That's how you do the intercepts. If you look on your sheet right here, now we just finished 17. 18. I just showed you 18. Okay. Well, there's their work, which is fundamentally the same. Okay, given this one, find the x and y intercepts. Okay, let y be 0, solve for x, so you get the point 4, 0. You see that produces 4, 0. Okay, 40 is the x or the y-intercept?
One.
X. Y-intercept always x has to be 0 because it's on the axis. XY axis. Okay. Okay, the point 0,4 is here, or 40. I mean. This is the point 40, which is what these two generate. That is the x-intercept, where y is neither up nor down. Okay, if you do the other way, then you get a point, let's call it over here, and I'm just going to make this up, 0, 3. Okay, this is the y-intercept, it's on the y-axis. X has to be 0. Okay,
So do we have to plug in 0 every time? Or can it be a different number?
well, if you're wanting to find the intercepts, yes,
Okay.
that's the procedure, that's the method. Okay. All right, let's go on. This is just a continuation. They used not 2, but 3, okay? And you got that. And there's their line based on their problem. This is the x-intercept where it crosses the x-axis. This is the y-intercept where it crosses the y-axis. And you can check it if you wish. Okay, given this equation, y equal 1/4 plus x, what is the y-intercept on this problem? There's a hint in here, a clue. Y equal mx plus b. What's b got a b in this problem? 0. It's not there. So b is a hidden 0 in this problem. So what does that tell us? Well, it tells us that the y-intercept is the point 0, 0, the origin. Okay, y equal mx plus b. Y equal 1/4 x plus 0. Okay, if this is the y-intercept value, notice I put the word value on it because the y-intercept always has to be expressed as a point. Okay, then that means on the y-intercept, the y value is 0. And by definition, x also has to be 0. So the y-intercept then is the point 0, 0. What?
It's half the job already done.
Yeah. Yep, just from that alone. If you use the hints that it'll give you. Now, to find the x-intercept, then we got to do a little bit of work. Not a whole lot in this case. Y equal 1/4 x. Well, for the x-intercept, we let y be 0. We let y be 0 for the x-intercept, right? Because the x-intercept has to be in the form x 0 because it's on the x-axis and y is 0 on the x-axis. Okay, so 0 equals 1/4 x. multiply both sides by 4/1, 4/1, x equals 0 also. What is that telling you? Well, it's telling you that this line is going through the origin. Now, we can graph this thing up 1 over 4. Up 1 over 4. Rise over run. So in reality, this is a line that looks like that. They're going through what we did, except they're doing it. They did the y first and the x last. And they get the same line we did. You're not supposed to hear my knees snap, crackle, and pop as I went down there. We're not going to spend much time on this. Some people like to know, what do we use this for? Okay. This trucking company buys a new truck for 65 grand. Okay. It is depreciated. It goes down in value $13,000 times however many years it is. Does that make sense?
Mm-hmm.
Okay. Now, to plot this thing, they're just doing the intercepts. I'm skipping over that word, but they're replacing the x with 0. They're replacing the y with 0. And they get this. The y-intercept out here is this. Originally, this truck was worth $65,000. But at the end of 5 years, supposedly, it's worth 0 for tax purposes. Okay, it still has value that they could sell it used. Okay, but after typically business depreciation is 5 years that they write it off from taxes. And that's what this problem is. There's a problem kind of like this one on the test.
So how do they get 5?
How did they get 5? Well, let me back up. Right there. Okay. In other words, they'll let y be 0 and solve for x. Okay, now, you okay now? Okay, well. I've said this already. Consider 2 points on a line. Slope is the ratio of the vertical change between the 2 points with horizontal change. Now, in English, it's 30 feet from here to yon, approximately. Okay? If I tie a string here and I tie a string at the bottom of that light plug, which is roughly 12 inches a foot above the ground. Okay? Then I have a slope of up 1 across 30, or 1 to 30, or 0.33% as a percent. Okay? Now, that's what slope is. That's what this thing is saying. We measure how far it is long ways. We measure how high it climbs. And we put the rise over the run, and that ratio or fraction or percent is how we measure slope. Okay, and here's just saying the same thing I just said. Okay, and I told you that for 2 days. Here's a picture of what I just showed you. By the way, when you get to calculus, they call this delta y over delta x. Delta meaning the amount of change. It's a Greek symbol delta, which is basically a triangle. Oh, what do we got here? Anyone been on this particular train? This is a world famous train. This is the Durango-Silverton Railway in Durango, Colorado. It's paralleled by the $10 million highway that they built along the ridge tops parallel to the railroad. Now, if you look down there, and by the way, I was one of those idiots leaning out the cars taking pictures. If you look down here, 400 feet distant is the river. And it's a level 4 rapids river, which means pretty harsh. Okay. When this train left the city of Durango, it was 3 feet above the river. Just the amount they had the tracks raised up. Actually, it's probably closer to 5. Anyway, in the distance that it has gone from there to here, it has increased its altitude, its angle of height, almost 400 feet. Now, in real life, and this is, a train can only handle a grade of approximately 1.5%. I just showed you a 0.3%. So about 4 times steeper, and that's it. Now, what do they do if they can't pull it? They add extra engines for track people, or they add extra weight to hold the wheels to the track better, or take fewer cars off. Okay? That's in my backyard. I also have a garden railway, among other things for hobbies. Notice the track down here. By the way, each one of these cars is roughly 4 inches tall, 4.5 maybe. But look how much higher this engine is right there than it is right here. There's a trick they use in engineering, and I initially started college as a civil engineer with the idea of building highways. Okay? No, I did, seriously. Lots of things. Lots of things. I also had a full ride music, played trombone and baritone and sousaphone with a traveling jazz band and symphonic ensemble. Full ride scholarship for music, even though I was in engineering. So go figure that. Back to this. Now, notice how much higher this is. And I'm looking at this thing almost level. I have increased the grade significantly. My model trains are very little more adept at going up hills than real ones are. You know, it just really can't be very steep. Now, how did I manage to get this up there from back here, which is even lower still? I increased the run. If I had tried to go straight from this point to that point, there isn't any way that engine could have made it. It just sit there and spin its wheels. Okay? But by increasing the run, therefore reducing the angle of slope, I was able to get it up here. Okay? There's my village.
It's a nice looking.
Okay? Now, yeah, by the way, my second car looked almost identical to that one. It did, serious. And several of the cars and things I had on there represent family things, even some of the store names. But at one point, this was too steep going around that same curve that you see down here. And I had some issues. So this board right here, these boards you see there underneath the track are 1 inch and 3/8 thick. They're actually vinyl wood, artificial one. Okay. And they raised it up that much. And by doing that, I was able to get the whole area to a level that was negotiable. And that's after I refilled the gravel. Well, here's another view of the train, a couple of them. Quite an elevation difference between here and there. But how do I do that? Oh, I added in a new section of what I call ladder roadbed. Actually, it looks like a cliff. At one time, the track went down like this with a 4.7% grade. I could only go downhill. I could only go clockwise. But with the new ladder roadbed, I was 0.8. Here's continuation of that roadbed being built. That's a viaduct that's connected to. And this is what it looks like now. I covered all that framework with chicken wire and hand laid concrete and stucco in there, and it was dyed. And I also made a Mesa Verde diorama to it. Now, let's go on to some other things. An old grain warehouse. What do you see here? Rise over run. Okay, pretty steep, pretty steep. Why would they build it with such steep embankments? Because Kansas has hail. Consider, most houses in Florida have very shallow or even flat roofs. Okay, what do they have? Straight wind, horrible things. Okay. In Kansas, although we have tornadoes and not much you do if you're in the way of that, we do have hail. And if you have a steeper roof, the hail will shuck off rather than penetrate. Okay, so it's a consideration again in engineering. Slope is. Anybody ever been on that road? I bet a bunch of you have. It's between here and Emporium on the Kansas Turnpike. Why the heck do they do all this curving around to get up there instead of just shooting straight across? Because it would be too steep.
Yeah. Otherwise, it's just,
so they lengthened the path, they increased the run by putting curves in. And in fact, that's what they do for switchbacks in the mountains.
that's looks.
Okay? All of these loops are increasing the run instead of trying to go straight from there to here, which would be impossible. You need repelling ropes.
Yeah.
Actually, that one's in China, I believe that one is. Okay, this one's in Los Angeles at night. Which brings us to this sheet that I've given you with all the formulas for slope. Snuck that one in, didn't I? You guys are starting to like having a slideshow in their work. Can't be having that too much. Now, what have we studied so far out of this list? We've studied this one right here, haven't we? We've studied that one and that one. And that's really about it so far. Guess where we're headed?
Yep.
The others. Okay, well, here's another slope. You can do a wordy problem on this one. You got a ladder leaning out 5 feet this way, 15 up that way. How long is the ladder? Usually you know how long is the ladder and not know how tall it is. Anyway, they did it this way. Well, change in y, 15, over change in x, 5. That ladder is at a 3-to-1 slope. Okay. Means you climb 3 feet up for every foot sideways. Okay, here's a shallow roof. And we're going to skip that one. Let's go to the slope. No, I want to get stuff covered tonight. The slope of a point of a line passing through this point, whoops, this point and that point. That represents 2 different points, whatever they are. Okay. So to do that, here is the formula we're going to use. You absolutely must have that formula memorized, or you will not be successful on your test. Okay. That's just kind of laying it out there. Now, you got a disclaimer here. All this disclaimer is saying is you don't end up with 0 in the denominator. Okay, it's got to be numbers where you don't get a 0. Because what happens if you got a 0 in the denominator? Undefined. Okay, here we got our rise over our run. Once again. Now, 2 points. Just 2 points on the graph. Let's see if I can graph those. 1, -1. 1, -1, right here. Okay. The other one, 7, 2. 1, 2, 3, 4, 5, 6, 7, up 1, 2. About here. Okay. Means this line goes something like this. All right. Now we can figure out these intercepts, but that's not what this problem is about. So what we want to know is what is the angle compared to horizontal of this line, which is what slope is, of course. Well, you need to call one of these points point 1 and call the other one point 2. And it does not matter which you call which, as long as you're consistent after you do. Okay. Now, I usually call the one most on the left point 2 and the one most on the right point 1, simply because it's easier for me to put it in the formula, and I'll illustrate that in a moment. Okay, so here's my formula. I take the y value of the second point, 2, minus the y value of the first point, okay? Okay. And I divide that by the x value of the second point minus the x value of the first point. Okay, and I got a double negative here. I got to deal with it. So this simplifies into 2 plus 1 makes 3. This simplifies into 7 minus 1 makes 6. So the slope of this whole line is up 1 over 2. Up 1 over 2. Okay. So the slope is 3/6. Well, reduced is 1/2. There it is prettier.
So you want us to simplify it?
Always.
Okay.
If it can, it must be. Okay. Find the slope of the path passing through these 2 points. Now, I'm going to work this one myself. I told you that usually I call this point 2 and point 1. Just because it's easier for me. Here's why. When I get ready to do this y2 minus y1 over x2 minus x1, then it naturally forms left to right, left to right. Okay? Now, let's talk procedure. If you expect to see partial points on a test, you better write that formula. Actually, you better put m equals in front of it. Okay? Now, I'm going to do my substitution. Y value, -4 minus -1 over 3 minus -5. Okay, that in turn becomes -4 plus 1 over 3 plus 5, which becomes -3 over 8. So m equals -3/8. Now, remember this -3/8 can be written -3/8. It can also be written as -3 over +8. It can also be written as +3 over -8, right? For the sake of graphing. Now, let's look what happens. Okay, from some point, I don't know, I'm just going to arbitrarily pick a point right now. This may or may not be the right one, but I'm just going to arbitrarily pick the point 0, 1 as my starting point or base point. That means that I could go down 3, 1, 2, 3, and right 1, 2, 3, 4, 5, 6, 7, 8. That means I could go up 3, 1, 2, 3, and left 8. And that's how you do it. Now, something you need to know. If the slope is negative, look what direction this line went. Look what direction this line went. If the slope is negative. Starting at the same place. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Now, see what happens when the slope is positive? See what happens when the slope is negative? My high school English teacher used to tell me that she could read our mood in our papers. Okay. She wouldn't let us use lined papers for our composition. We just had to use plain typing paper. She would say to us that if I see you writing uphill left to right, that generally you're kind of positive about what you're saying. And then if you tend to go downhill left to right as you're writing, that maybe things aren't quite so cool or you have doubts or whatever. Okay, this is the same way. You always read graphs left to right. If they go uphill left to right, you got a natural positive slope. If they go downhill left to right, you've got a natural negative slope. Okay? And that kind of thing, the uphill, downhill kind of stuff is going to show up in some other stuff later in the course too. Yes.
What happens if the slope, if you do this formula and it comes out as 0, 0?
Well, the slope won't come out 0, 0. That's a point. The slope is a ratio, a number of rise over run. Now, the slope could come out a slope of 0, which is a horizontal line. Okay? That is possible. Now, what if you came out with a slope where you had a 0 in the denominator? Then that means it's a vertical line and there is no slope. But do you see why I usually call this 1.2? Because it just
Makes everything easier.
nicely falls into place. And you don't have to think about it as much. And I prefer not to think if I can avoid it. Okay, well, here's their work on the same problem. Okay, we got these 2 points. Now, you two, you guys really try this one. I'm not gonna go through this one first. I'm gonna sit down. Whoops. Oh, okay, you guys forget what we were doing. Sorry about that. I've got to go on. I'm gonna get everything covered. Well, here's another one. Okay, they put it in. Ah, what is this telling me? No slope. Bingo. Undefined slope.
So it's a vertical line.
And yeah, that's a vertical line.
So could you write slope?
Just like undefined.
What?
Only for horizontal.
In this one, your only correct answer is the slope is undefined.
He's got undefined, and it's undefined.
Ideally, you would put undefined slope, but they just wrote the word undefined. You really want to ask that question? Because then I might be forced into an always answer and not be able to have mercy.
I just need to know so I don't. Cover my.
Better to do than to omit. But like I said, you can always hope for mercy. Okay, here's another one. Uh-oh, look at this. I'm throwing something in here. The Y values are the same on both of these. What kind of line is that? That's a horizontal line at Y equals 2. 2 above the origin. Okay, so what's the slope on that one going to be without even doing any calculations?
0.
0. Okay. Although you can do it the hard way, you'll get the answer of 0. If you don't happen to catch that. Okay. Parallel and perpendicular lines. If you notice, this is like number 19 and 20 or 21 or something like that on your list. I think there are like 3 problems on parallel and perpendicular. Okay. Now, let me back up. If the lines are parallel, they have the same slope. That's what this is saying. Slope of the first line is going to be the same as the slope of the second line. Okay? They're just spread apart, but they're parallel or whatever. Okay? For example, these two. Now, what this is saying is if neither one of them have a zero slope and they represent perpendicular lines, then one over that opposite. Now, the way I word this, the way I word this is the opposite reciprocal. Reciprocal is when you flip a fraction upside down. Okay? So in the case of slope, if you had a slope of 2, it'd be 2 over 1, and then you'd flip it and make it a half. And then you go to opposite sign if you want perpendicular. Remember, parallel, same slope. But perpendicular, opposite slope, reciprocal, and opposite sign. Now, look at the slope of this line. -7/2. Look at the slope of that one. +2/7. Okay, that and this are reciprocal, opposite reciprocals. They will meet in a 90-degree angle. Okay, suppose it has a slope of -5. What's the slope of the parallel line? -5. Okay, what's the slope of the perpendicular? +1/5. Okay. Now, here, they're just giving us points. We're going to go through the points through the slope formula. Okay, and here's the work on this. They're just showing you this. Okay. A line going through these 2 points and a line going through those 2 points have to be perpendicular to each other somewhere. You know, they got to cross at some angle. Okay, now we're going to skip the applications. Well, actually, there's one that looks a whole lot like this one on the test. This is called curve fitting. You're drawing a line through the set of points that kind of averages them out. And then based on that, you pick 2 points that are pretty much on the line, and you do a slope to get the percent of increase, how much that company is increasing in value every year. That's what this is about. You look a little puzzled. Okay, let's say I'm going to take a real easy number. Let's say this slope was 3/4. Okay, which would be an upward slope. Percent of increase, that would be 0.75 or 75%. Just convert it to a percent, a fraction. Okay, did that answer your question? All right, well, here's their work on that problem. And ultimately they got it. 0.64. Well, my 0.75 wasn't that far off. Okay, now. Point slope formula. That's our next important product. It's on your handout sheet. You'll work that sheet's out on top. Will you hold that up? Point slope formula. That's what we're looking at now. Okay, this is the slope intercept form. Slope intercept, right? Which is basically the working form for linear equations. Now, in this, M is the slope, B of the y-intercept is the B value. Given this one, we need to rearrange that so it's in y equal mx plus b format. Okay? So what we do, we took the 3x over to this side, we divided everything by 4, and we got this equation transformed into that. You're going to have to do that in a lot of problems. Okay? Convert from y equal mx plus b, or from standard to y equal mx plus b. Now, this says you're going downhill, 3 down and 4 right. And it says you're going to cross the y-axis at the point 0, 1. Did you hear it say all that stuff?
No.
No. Okay, well, they did. All right, so there's the slope of the y-intercept. Let's go on. Now, here's that same problem again. Plot the intercept. And here's the slope. The 3 variations I told you about. Up and over, down and the other way. So here's our line generated by that equation right there. Okay? We take this 1 right here as our base camp, and then we go down 3, right 4, down 3, right 4, or up 3, left 4. Yes.
So as long as this is the slope and I remember is opposite side of the negative with the slope, is that always separated, like, do I do going up or something?
It'll work either way, going up left or down right on the negative. Okay, so now I've got these 2 questions. Are they parallel, perpendicular, or needed? And you got 3 problems on your test like this. The last 3 problems on the test. Yeah. Okay. Now, let's work these. You got that information, and you got this. The slope is -2, you got the intercept. Okay? In this case, the 2 problems, the slope is the same. The intercepts are different. So we know that these are parallel. Okay? They're at some angle in space, but they're parallel. Again, this one, we can't tell right now. We got to change this to y equal mx plus b format, which is that and that. So we got a slope of -3/2 on the first one. We got a slope of +2/3 on the last one. Opposite sign, flipped, so they are perpendicular to each other. Okay, but this is how you tell. And this is the first step in the next set of problems. Okay, I'm going to skip through the next one of these and get into this. Slope intercept form. Okay, find it on that handout sheet, packet sheet. Okay, y minus y1 equal m times m minus x1. That is the equation finding formula. That is the equation finding formula. Now, I know some of you were taught a different way in high school, and you're welcome to use it, but it's easy to make an error. If you use this formula, plug and play, sub and solve, you're not as likely to make mistakes. And again, this is a memorization formula. Okay, now we got a slope there. Okay, now what did they do here? This is that substitution method that I was telling you to don't use. I put one problem with that. Here's the way I want you to do it. Okay, there's that formula I mentioned. And I want to physically see that problem. Seeing that formula where it's appropriate is a 1 point by itself. Okay. Now, you got a line has a slope of -3 and it passes through the point 1, -4. That's two pieces of information it gave you. It gave you a point and it gave you the slope, hence point slope formula. Okay. Now, here's just restating the information. Here's the formula again. We're going to substitute the y value because y minus y1 here, y value equals the slope x minus x1. Okay, so we just take these two values and put them in here and here and the slope there. And it'll always be done that way. Now, it gives us that business. We need to simplify that. We need to distribute this -3 and eventually get that 4 on the other side. So we got a y equal mx plus b answer. So let's distribute that 3. We did. Now we're going to add -4 to both sides. I want this over there. So -4 here, -4 and +3 makes -1. Okay. So, whoops, if I go too far, actually, that's it. That's the answer. We're done.
You can go back just 1 minute.
Absolutely. Okay, what I did here, here's my formula. I took the two values of the point. Here's the x value of the point. Here's the y value of the point. And here's the slope value. I subbed them in, which gave me this. Then I simplified it. Ending up with y equal mx plus b. This is the equation of the line, okay, that passes through that point and has this slope. Okay. In other words, 1, 4, 1, -4, right here. There's 1 point, and then the slope is -3. If I were to start with this point, I've got a slope of -3 over 1 or +1 over -3, right? Oops, I said that backwards. +3 over -1. Don't want to go flipping that unless I'm going perpendicular. Now, from this point right here, if I go up 3, okay, 1, 2, 3, and left 1, I get right there. From this point, if I go down 3, 1, 2, 3, and right 1, I get right here. That's what that line actually looks like. Okay. See, it crosses at -1. The y-intercept is -1.
So when we do point slope equations, do you want us to graph them as well?
Only if it asks you.
Okay.
Only if it asks you.
Okay.
And I just did that to illustrate what that equation was. Okay, here, this time we got 2 points. What can we do when we have 2 points? We can find the slope. So we do, and we get the slope as -1. Now, we can take either one of these points and the slope and find the equation. Okay, using the point slope formula. Okay, there's the point slope formula. It appears to me that they chose this one as their point. If we had chose this one, we still would have gotten the same exact equation in the end. Okay. Now, so anyway, the 3 goes there, the 1 goes here, the slope goes here, and we simplify it. And that's the equation of that line. What do we know about that line? It goes downhill. Okay. Now, we got a point. We got a line. I want to find a second line that's parallel to this line and also passes through that point. Well, what we got to do is from this equation, we got to find the slope, which in this case is -4. Okay. So now we have this point and we have this, and it wants parallel. So we're going to use the same slope. If it asks perpendicular, then we would have to use positive 1/4. Everyone understood that, right? Okay. So anyway, I'm going to substitute -4 for slope and here for the point. There's my formula. There's my substitution. The only reason they got these brackets and stuff is because of the minus and negative. You wouldn't necessarily need those. Okay, so carrying on, we're going to distribute that 4 now. Now,
Oh, you want under the 2?
but
That now reference to
now we're going to take the 3 over. And here is the equation of the line that's parallel to this one and passes through that point. We've got one more skill to do tonight, barely enough time to do it. What do you suppose that one more skill is? Same problem, only the word perpendicular. Same problem, only the word perpendicular. Okay, or similar problem. Okay, so and there's my parallel lines, what they actually look like. Okay, now this one, let me erase my scribbles over here because I've already got some free scribbles. Okay, in this case, find the equation of a line passing through a point perpendicular at a right angle to this line. Okay, so what's the first step we got to do? Find the slope of this line. Well, here's the work on that. So what is the slope on this line? -2/3. Okay, you look a little puzzled. No? Good. Okay, anyone else? Doesn't see what I did here? All right, so anyway, we got -2/3 for the slope. We really don't care what the y-intercept is on this particular problem. Okay. Now, so we're going to take this, we're going to do the opposite reciprocal because it wants perpendicular. And then we're going to use this point with the point slope formula. Okay, that's just reiterating what I said. So if this is the slope of this one, then this is the slope of the new one. We could call this M1 and M2 if we wanted to. just to designate it. So we're going to use this slope, and we're going to use that point in the point slope formula. Okay, get a head start on it. Get a head start on it. We're going to use this slope and that point using the point slope formula. I just shown that that's 0.2 right there. And what this is this is just converting that to the -2/3 they already showed you. Okay, here's my point slope formula. There's my point. The 3 will go here. The 4 will go there. The +2/3 will go there. Like so. Everybody get this far okay? Okay. What messed you up?
At the variables equal y minus y1 equals 4.
These are always the y and x. That is always the m.
I just put them in the wrong places. That's where I got messed up.
Well, here's the formula you should be using. Okay, so anyway, this thing simplifies to this. 3/2 x. 3 times 4 is 12, divided by 2 is 6. Okay. Now I'm going to add negative or +3 to both sides. Now, I need to warn you about something. I don't think I've got any like this on this test, but I guarantee you will have some in the future where between this number and that number, you've got to do a common denominator fraction kind of a thing before you can add or subtract them. Okay. I don't think I've got that on this test, but that can and will happen too. Or you just have to do the common denominator game to add fractions and whole numbers or fractions and fractions.
How did you get,
Where?
how did the -4 change to -6?
3 times 4 is 12.
Simplify that down.
3 times 4 is 12. Divided by 2 is 6.
So you
Okay.
have to distribute that 3/2 throughout that parentheses and make sure that's the problem. So
Basically, that's what you're doing here. Okay. 3 times 4 is 12 over 2 equals 6.
Okay.
All right, continuing. Whoops. Actually, I finished. We take this 3 over, add 3 here, add 3 there, you get -3. So this in turn is the equation that is perpendicular to that line and also goes through this point. Okay. Now, that's all of the topics. I hated that I had to rush as much as I did tonight, but I had to. Good luck. If you want to look at this again, I'll probably have it in my YouTube channel probably sometime after 11 tonight. If you want to see it again for good luck. I'll see you Thursday. Let me ask you. Do you have any questions before I close out?
Yes. Will we get that worksheet tonight?
It's actually online already. If you should have gotten an email about it through Blackboard, that it's posted. There's an announcement with a link, and then it's also in the course materials.
Okay, I'll go look at it.
Yeah,
So
but you
we
should
have
have
a,
gotten that about mid-afternoon.
okay, so we have a test this Thursday?
Well, in the case of your class, your test is going to be online. It will open at 7 p.m. Thursday night, and it'll be open until Saturday. And you'll be able to do it sometime during that window. And it'll be graded online on the spot as you do it. You need to kind of